Um, First thing we're going to do is we're going to spend some time reviewing the example that we had last week relating to inheritance. And what we did is we created a application. We had part of this before where we had the pizza class and the order class and the unit test class, and we added a delivery order. And we said a delivery order is just like a regular order, except it has some extra stuff. Now remember our criteria for whether you would inherit one class from another. We said that you can inherit a class for another if there is an is-a relationship. So if we look at order and delivery order, a delivery order is an order. So we can inherit delivery order from order. All right. What does that mean when we inherit? It means that we get everything that's in the order class, plus we can define additional things. Now, the one exception of that is constructors, which we'll talk about in a few minutes here. So let's revisit this application. And here I have the order class where nothing in that order class changes. It still has a name and a phone number associated with it, and it has a list of pizzas. We changed this to protected because we want the subclasses to be able to refer to these variables as well. In the delivery order class, we've defined some new attributes. So in addition to the name, phone number, and array list of pizzas that is in a regular order, a delivery order also has an address, a city, a state, and a zip. And it will have the appropriate set and get methods for those additional attributes. Finally, we have a brand new function associated with an order, with a delivery order. That is calculate delivery time, which is defined as simply the bake time plus an additional 30 minutes to deliver. So if it takes 20 minutes to bake the pizza, the delivery time is 30 plus that, or 50 minutes. To calculate the price is the same thing, same price as a regular order, plus an additional $5 delivery charge. Now notice this is a brand new function. There is not a calculate delivery time in the superclass, in the order class. There is a calculate price function in the order class, and this overrides it. So if we call calculate price on a delivery order, this is the function that we will get. Right? We talked about constructor chaining and how you have to make sure that the constructor of the superclass is called first. And we do that using the super command. So if we have a constructor for delivery order that consists of these 6 elements, we call the superclass to address those attributes and then address the other attributes in the constructor. So this constructor calls this constructor. If we omit calling it, the constructor is still going to get called on the order class, but a no argument constructor is called. Right? So we did this, we ran some tests. Let me go to the command line. So we can compile these. and we get an error. I must have saved this with an error in it. Calculate delivery time. Let's see why we have that error. We have that error because in the unit test class, we create an order D of new delivery order type. And we're allowed to do that. We can put in a variable that points to an order, a delivery order, because a delivery order, after all, is an order. So I can declare the variable as containing a pointer to any kind of order that we have. And which one are we creating? We're creating a delivery order. However, what the variable is declared of on this side limits to what methods we can call. So we cannot call to calculate the delivery time of the order, because that method does not exist in the order class. That only exists in the delivery order class. If we declare the variable D as containing delivery orders, then we're all set. And then if we compile it, we will no longer get the error. I'm going to leave that error in the example and hope that you watch this lecture and know how to fix it yourself, be able to reason it. Okay. That is the review of what we went over last time. What I want to do is I want to extend this example, and hopefully extending this example will allow us to reinforce some of the points that we had before. Let's say that we have a brand new kind of pizza, and it is a stuffed crust pizza. All right. And the way that you calculate the price of the stuffed crust pizza is different. Right? It's different because a stuffed crust pizza, instead of the amount for a regular pizza, we'll say a stuffed crust pizza is $12 for a small, $16 for a medium, and $20 for a large. 12, 16, 20. All right. And a stuffed crust can either be thin or thick also. You can have a thin stuffed crust or a thick stuffed crust. So, is it correct to say that a stuffed crust pizza is a pizza? Yes, it is. Or we can say is a kind of pizza or type of pizza. So yes, we can say we have pizza as a superclass, and we can have stuffed crust as the subclass. Now, the only thing different about a stuffed crust rather than a regular pizza is small is 12, medium is 16, and large is 20. So let's go and let's create the stuffed crust pizza class. So I can go here and I can say File, New File. And it is going to be stuffed crust pizza, Java. I always do this wrong. There we go. Oh, I forgot to save it. So let me save this. Right, we're going to say it is a Java class. Okay. So this inherits from pizza. So I'm going to say public class stuffed crust pizza extends pizza. And we have our braces that go around the body of the class. Now, that means that all of these things, other than the constructors, get inherited by the new class. So we don't have to define that there's an attribute called size, an attribute called crust, an attribute called has pepperoni. I am going to make these protected, as I said before, so that the subclass can also use them. But I don't have to redefine them in the subclass. That's what inheriting means. It means you get everything in the superclass, plus you can have additional things, or you can change or override functions. So there are no attributes in the stuffed crust pizza class because I said it has everything that a pizza does. Now, I did say that price I'm going to copy it to make it easier. The price is calculated a different way. All right. If it's small, it costs $12, I think I said. If it's medium, it costs $16. And if it's large, it costs $20. And then we'll add $2 if it has pepperoni on it. That's 2 for pepperoni. Okay. Now, if I do this, all right, this is not going to work. I'm telling you this right now. All right. I've not defined any constructors. That's going to get me into trouble. And I want to make sure you understand that and understand how that gets you in trouble. So what I'm going to do is I'm going to create a new pizza. stuffed crust pizza equals new stuffed crust pizza. Now remember back from something we talked about earlier on, if you do not define any constructors, which we have not done in this class, the compiler automatically generates a constructor with no arguments. So maybe I'm able to do this. Maybe I'm able to do this. Save all. And I'm going to compile it. You could probably tell how I'm talking that no, I am not able to save it. Well, my first problem is I spelled public with a capital P by mistake. Okay, let's make that change. That was unintentional. All right. Here's the error it gives me. It's giving me an error saying that it's trying to create, there's no suitable constructor found for pizza, no arguments. It's looking for the no argument constructor on pizza. Why is it looking for the no argument constructor on a pizza? Because remember, when you create a superclass, it first has to create the subclass. If you don't define any constructors, it will define a constructor for you that accepts no arguments, and it will call these superclasses constructor that accepts no arguments. So it's looking for, on the pizza class, a constructor with no arguments, which of course we don't have because we've defined our own constructors. So how do we fix this? Well, the way that I'm going to do it, because pizza and stuffed crust pizza have the same arguments, I'm going to copy over the pizza class's constructors. If I do this, is this going to work? No, it's not going to work. Why not? Because now I have constructors. However, I haven't, at the beginning of the constructor, called the superclasses constructor. So likewise, it's going to give me an error. Because I still, even if I call one of these constructors, so that's going to call the two argument constructor on stuffed crust pizza. We'll call this guy here. However, I have not said which superclass constructor I want to have called. And therefore, it's going to give me an error because it's going to try the no argument constructor again for the superclass. And as we know from before, that doesn't exist. So we're going to get pretty much exactly the same error we got before. I spelled stuff wrong. Stuffed, not stuffed crust pizza. It thinks it's just a regular method then, because it doesn't match the name of the class. So now it's giving me pretty much the same error as before. Is looking for the no argument constructor in pizza because we haven't specified in stuffed crust which of the pizza's constructor we want. So the answer is going to be to do what we call constructor chaining. We're going to call the super class's constructor, and we're going to pass arg size, arg crust, and arg has pepperoni. Now, since there's nothing new in the stuffed crust pizza class, we don't have to initialize any other variables here. And we make that similar change to the other two constructors. So now, when we call the constructor on the stuffed crust pizza, we are explicitly saying which superclass constructor we want. And it's not, therefore, going to look for the no argument constructor on the pizza class. It will find instead the proper constructor and construct the pizza that way. Again, a spelling error. Now it's going to compile with no problems. There's a nice little page that sort of summarizes how constructor chaining works. You can use this to call the same class constructor, super to call the immediately super class constructor. If you use this or super, it must be the first statement in the constructor. We can't use this and super in the same constructor. We cannot add this in all the constructors of the same class. If you do not add a this or super, the constructor will implicitly add the super statement in the constructor that will call the superclass default or no argument constructor. So they have some examples in here of what gets called in what order. This is important, so make sure that you understand it. Now, what that means is we can also change the constructor in the pizza class. We don't have to, but we're going to. All right. I'm going to change this constructor to call the constructor in the pizza class that accepts arg size and defaults to thin. Then I'm going to call this one, and it's going to call arg size, arg crust, and default pepperoni to false. So if we call the one argument constructor and just past the size of the pizza. It's going to call the 2-argument constructor, which is going to default the crust size to thin. That will in turn call the 3-argument constructor and will call this function. It's just a good way to keep our code consistent. In fact, we can make one more slight improvement. We can say this set size, arg size. Use those set methods that we created. Now you might say, well, do we have to do this? It worked before, and the answer is that it works better this way. It works better this way because what happens when we add validation in? The way this code is written now, there's only one place that we have to test to make sure that the crust is initialized correctly. And that is right here in the set method. The set method is the only place that you can change the value of that size or crust or pepperoni attribute. So everything gets funneled to that set method. May seem like a small difference, but it is a huge difference when later on we get into exception handling and error handling. So now we go and do this, and we compile it, still works. Now, let's go and let's add that stuffed pizza to an order. Can I do that? Because if you remember, that variable SCP is a stuffed crust pizza. And the array list in the order class is an array list of pizzas. So can I add a stuffed crust pizza to an array list that contains pizza? And the answer is yes, we can. We can because the stuffed crust pizza is also a pizza. Now, we're only going to be able to call methods that exist on the pizza class for this array list. But as long as everything is a pizza, we should be able to add it to the array list. So, and my delivery order. We're going to focus on this last order. I add a small thick crust, regular pizza, a small thick crust stuffed pizza. Both of them have no argument for the pepperoni, so it's going to default to false, and then a large regular pizza. And it's a delivery order. Let's see if that makes sense. Let's make a little Excel worksheet to sum up. Small regular is 8. Confusing myself here. Small thick crust is 9. A large is a 10. No, my mistake. A small, regular crust is 8. Really do good if I commented this code about what the expected value was. So a small, thick crust is actually 9. I was correct the first time. A large with no pepperoni is 12. And third one is a small, thick crust, stuffed crust. Small, thick crust, stuffed crust was 12. So if I didn't mess anything up, which is possible, of course, the sum for this pizza should be $33, sum for this order. However, it's a delivery order. So a delivery order, we add $5 to the price. And should be $38. Let's run this and make sure it is. This is what you should be doing with your test cases, by the way. You should come up with a test case, manually calculate what the results should be, then run your program and see if you get the results that you expect. That's what a test case is. All right? So, compile it. Cost of order is $38, so we got the number correct. One thing that many programmers do, many inexperienced programmers especially, is they don't test their code adequately. Ideally, you would test every possible scenario, or as many possible scenarios as you can. What does that mean in this case? In this case, you would test some pieces that were regular, some pieces that were stuffed crust. You would test some orders that are regular, some orders that are delivery. You would test some with small, medium, and large sizes. You would test some with pepperoni, some without pepperoni. You'd test some that were thin crust and some that were thick crust. And you would document what you are testing, and you would test thoroughly to make sure that you have all your bases covered. Even an application as simple as this would have many different test cases in it. There's a resource about test cases, and this is pretty elaborate. We don't nearly have to go quite as elaborate than this. But ideally, you would prepare a worksheet, a spreadsheet, that would define your scenario. So for us, maybe our scenario is delivery order. With one small, thin, no pepperoni. And we would go and we would specify how long we expected it to take. So what was the delivery time? What was the bake time? And what does the order cost? Then would have maybe a pickup order with stuffed crust, large with pepperoni. Now, is it possible to come up with every single combination? In some cases it is, in some cases it isn't. But you should make some effort. I would not be comfortable unless my test plan contained both a delivery and a pickup order, contained all 9 combinations of, I think there's 9 combinations of pizza. Maybe there's more than that. Small, medium, and large. Thin and thick crust, pepperoni or no pepperoni. All the combinations of those 3 variables. And finally, a stuffed crust pizza and a not stuffed crust pizza. So as you can see, testing can get very extensive for these, but really that is one of the big differences that makes you and elevates you from being an okay software developer to being a really good software developer, that you thoroughly test your code. So for your next lab assignment, lab 6, I define a scenario. Publisher offers 3 kinds of subscriptions. I'm going to edit this right now to say use inheritance. Oh, I do already. Good. Three kinds of subscriptions: basic, premium, and student. Here's the attributes we need. Here's the methods we need. Create the relevant classes. And be sure to test thoroughly. It's not required in this example, but you should come up with a test plan. So the test plan would consist of, I would think, at least 3 test subscriptions: a basic, a student, and a premium. And you would set these properties, make sure that the renewal cost and the expiration date is correct. So I would go and calculate by hand. And I would say, and regular prescription, $15 to renew, or student subscription in this case would be and it expires on 2019, 10/1, and the cost to renew is $15. I would figure that out in advance and have a spreadsheet with that and make sure that the spreadsheet, the results that your code gives matches what your spreadsheet, what you actually manually calculated. You know, I'll see something like the student tuition program where there's all different kinds of combinations that you can have. And a student will run, and some students in class run 1 or 2 tests. That's not adequate. It could just be lucky that for in-county residents that the code is written correctly. Maybe for out-of-county or out-of-state, it is not correct. So it's important to test as many possibilities as you can. Now, in a case like this, we can literally test all of them. We can test the basic, we can test the student, and we can test the premium subscription. So there's no excuse for just having one test case here. You really can test all 3 scenarios. All right. What will this look like? Well, you have a basic. Well, I'll let you decide that. But you do need to use inheritance in this example. All right, now the one thing that this example has that we have not yet encountered is dates. And I have a little class here called Fun with Dates. That you can use to create date objects, because a date is an object, not a primitive, and do sorts of things to it. Like if you have the date, if a subscription was started today and it expires in 3 years, well, you can do the math to actually compute the date that it expires. Put it right on the desktop. Oh, that's a folder. Right? Then it shows some basic date functions. You have to look at the code to see what they mean. That's one thing that you should be doing in your assignments as well, is clearly labeling your output. Like I showed in the example, you would say that so-and-so, their prescription was gotten on this day, it expires on this day, and the cost to renew is so much, so many dollars. Let's look at the code in this Fun with Dates to see what some of the things I'm doing are. First of all, you need to import all of these things to do everything that I'm doing here. This will create a date object of the current date. This will create a date object having this month or year, month, day. There's another way that you can do it. So these are 3 ways that you can create dates, either the current date or you can assign a date. When you do a comparison, this is not going to work because this will ask, is date 2 the same object as date 3? And no, they are not equal to. However, if you use the equals method, that will say, yes, those are the same date. We notice in our output, the first thing says the dates are not equal, even though they're both set to July 4th. They're not equal because they are actually different objects, not objects with the same value. That's what this compares. I can take and add to date 1, 28 days using plus days. So for example, today's date plus 28 days is October 24th. I can tell if a date is after another date, if a date is between dates, and so on. Or rather, the number of dates between dates, I can tell. How many days is it until this date? How many days is it until this date? Looks like I did the same thing twice. You could also use months. Specify the units. Last one will tell you that it is 0 months because it doesn't round to the nearest month. It just truncates. So if it's 0.8 of a month, it will just say 0 months. Take some time to use this and understand it. For this assignment, you need to be able to create a date so that you can initialize the date in your subscription classes. You then need to be able to add, in this case, you will not add days, but you will add months. So you can add 12 months to determine if the subscription expires in a year from now. Or I think the one example, you could add 3 years to it to determine how to do it. So take a look at this, and this kind of gives you an idea, and you can play with it. So for the subscription, for the subscription line, would it make sense to say that the superclass would be subscription and there would be 2 sub classes? Yes, that is probably the way I would do it. I would have my main class be basic subscription, and then I would have 2 subclasses underneath it. One for student subscription and one for, what was the third, premium subscription or whatever it was called. So yes, that makes perfect sense. Did I see your first question from a while ago? Apparently not. Let me pull up chat. Even though subclass inherits all of the superclasses data, you still have to add in all of the superclasses constructors. The answer to that is have to is a strong word. All right. It's probably a good idea for you to do that, I guess, is probably the correct answer. That yes, it'll probably be a good idea for you to add in the constructors. So if there's a 3-argument constructor in the superclass, you probably will have a 3-argument constructor in the subclass as well. Right. Constructors do not inherit. Now that doesn't mean I couldn't think of some odd example where I wouldn't copy all of the constructors over, but for the most part, yes. Because the idea is a subclass is what has everything in the superclass plus extra stuff. So if there were 3 attributes I was initializing in the superclass was the constructor, I probably want to initialize those same 3 if I instantiate the subclass. Now there might be extras. So I might have, for example, like I did with the delivery order, I had the same constructor. I had the 5-argument constructor called the 2-argument constructor in the subclass, in the superclass rather. Let me bring those up to show you what I mean. There is the subclass, here is the superclass. Okay, there's one constructor in the superclass. To create an order, you need to know the name and the phone number for the order. Now, that doesn't mean I have a 2-argument constructor in the delivery order. All right. I'm actually expecting 5 arguments because when you create a delivery order, you don't just only need the name and the phone number. You need the address, city, state, and zip as well. So you won't always create the exact same ones in the case of when there's additional information on the subclass that's not in the superclass. So in this case, the 6-argument constructor calls the 2-argument constructor on the superclass. All right. Think of it as initializing attributes. What do I need to have an order? Well, I need the name, I need the phone number, I need the address, city, state, and zip if it's delivery. Well, those are attributes on the delivery. I need to initialize them to even have a logical order, to have an order that makes sense. I can't have an order without an address. All right, I can't default the address to anything. All right, so I'm going to have a constructor on the subclass that accepts all the arguments that you need, all right, at the time of creating the class. And then on the order, you only need 2 of those arguments, right? Because if it's just a pickup order, all right, all you need is the name and the phone. You don't need to know the address if it's a pickup order. So I call the super function and give it what the order needs. Now, in the case of pizza and stuffed crust pizza, there was no additional information for a stuffed crust pizza. It had all the same attributes as a regular pizza does. Therefore, the constructors match up a little more closely. And yes, I would have for every constructor I have in the subclass or the superclass, I would have a corresponding one in the subclass. Trust me, a lot of this sounds harder than it is. You just have to get into it, take a shot at things, and if you have questions, don't struggle at them too long. All right? Reach out and ask for assistance. And I'll be more than happy to look at your code and tell you what's going on and try to explain to you why it is the way that it is. All right, that's all I had for today. I'm going to post this example and we'll go from there. Did you have any more questions? All right, take care. We'll talk to you later.